subject of hybrid analysis in CATIA, and some of the tutorials that I'm going to be preparing are in line with chapter 19, but there are some major differences, and I may be doing this thing in several different ways, different from what's in the book. The problem, let me show you what chapter 19 is about. So you have a structure like that, and when you look at this, it seems that everything is made of solid elements or solid geometry. However, you should realize that, for example, these cables, or if you want beams, they have to be done with specifically beam element. That platform in the middle, it has to be done with shell element, strictly speaking, to be more efficient. And then, of course, the cylinder in the middle is solid element. Okay, so at the top of these two cables or columns or clamp, the bottom of the cylinder is clamped, and the surface of this platform here, the horizontal platform, is subjected to uniform pressure. When you look at this, there is a plane of symmetry. It's a single plane of symmetry, but in the book, this was not used. So my approach in this first tutorial is going to be exactly the same way. And the other thing that I'm not going to do is to use the advanced meshing tool to create a fancy mesh for example, the platform, horizontal platform. I've repeatedly said that some of the chapters in the book to take you to the advanced meshing tool, which is very important, but is not the focus of this point. You have to know the fundamentals of it, what it's good for, etc. Okay, good. So the dimensions, I will stick to the dimensions that I have, more or less. But let me put it this way: I'm making an assembly product file here, or an assembly made of a cylinder. The left, let's say the left column, the right column, and the plate. Okay, so. All right, let's do it. Insert new part in there. Why don't I make the cylinder first? Okay. Yeah. Okay. So let's call this thing properties. So you say vertical cylinder. And vertical cylinder. Okay, so let's make it. So on a convenient plane, say on this horizontal plane, I will sketch a circle. Let me make the diameter of this cylinder 1. I'm trying to be as much as consistent as I can be with the sizes in the book. So this is going to be diameter 1. All right. And then exit. And why don't we pad this thing by 2 inches, see how it looks like. You know what, actually let me do it 2 inches, but let me do a mirror extent. And the only reason I'm doing it as a mirror extent, because I want to be able to draw that platform on the XY plane. Alright, what does it look like? Yeah, okay, that's not too bad. Alright, let's save this thing, sir. File, save management. This is the product, save as, desktop, new folder. I will call it chapter 19. I'll call it 1, okay, because I'll do this thing, or say, yeah, no symmetry. No symmetry is used. Okay, that's what I mean. There is symmetry here. On the test, you have to do that. Okay, then we're going to insert the platform, horizontal platform. Insert, new part. And let me rename this thing to be horizontal platform. Horizontal platform. And right here, horizontal platform. And we're going to make it. Double click on it. Okay, in the book I have made a solid object and then extracted the top face of it, something like that. I made it like that and extracted the top face of it. This is not the approach that I'm going to do. See, this is how it's done. Extracting the top face. Let me show you. Scroll down. Right there, extracting the solid face, the face on the top. Well, I'm not going to do it like that. I'm going to create it as a surface. Okay, so on a convenient plane, this plane, I will sketch. Alright, so my geometry looks like this, and I'll clean it up in a minute. Trying to incorporate as much as I can with those dimensions. Okay. It looks like this is not completely centered, so this line, control that line, control the middle axis. You make it symmetric, shift it a little bit. Alright. Now, the other thing is dimensions. Okay, so what are the dimensions? 2, 2, and 1. So this is going to be 2, and so is this one. This is also going to be 2. Okay, and obviously the radius here is going to be 1. Okay, good. Exit. Now, I would like to make a surface out of this. And first of all, as soon as you say surface, you have to be wireframe surface design or generative shape design. It's up to you. So let me switch to wireframe and surface design. Mechanical design, wireframe and surface design down here at the bottom of the list. And then you use a fill, something called fill. These are different important ways of making surfaces. One of them is here. If you have a cold surface, you can select it and it's going to put a surface on it. Okay, however, I do want to make a hole here. So maybe the easy way of doing the easy way, you can go on this face and draw a circle and then cut it, or you can just project that circle onto that and then cut it. So on that face, we sketch. I want to project that circle. There's a project right there, as you can see right here, and exit. As a matter of fact, you can hide this solid cylinder or vertical cylinder. So I have a surface here and something on it. That's circle that I would like to cut it with. So where's the saw here? The saw is right there. It says what is the element to cut? Is that fill, basically that thing that we created, and the cutting element is this circle, and we want to keep the outside of it. Now you can see that right here, this can be shown here. So we have a surface and we have a solid cylinder. Now in the book, as I said, I created solid object, extracted top face, and all kinds of crazy things that is not needed. Well, I mean, you get to learn these things, but it's not needed. All right, now, what we would like to do, we would like to insert the left column and the right column here as separate parts. So let's go here. Or you can do it at the same time. You can do it at the same time as column. Okay, so I don't know. I haven't decided exactly. I'm gonna make them separate part. Insert new part. Oops, I've got to go to, first of all, product, save everything just to make sure that we have to kill the job. All right, so insert new part. I call it left column. Properties left column. Left column. And let's make it. Now, that column is starting at this point and it's going to go up. So let me create a line there first. A line. And the method of doing the line is going to be a point and a direction. So the point is right there. This is the point. And the direction is direction Z. And the length, the height that we're going to go up. So let's go up by maybe 3. See how it looks like? Good. So that is the left column. All right. Okay. Now let's do the right column. We repeat this thing. So back to the product. Insert new part. Call it the right column. Properties. Okay, right column. And right column. Okay, let's make it. Go here. Once again, you're going to create a line. Point and direction. For the point is this corner point over here. For the direction Z. And for the height, I think I put 3 in the other one. Good. Okay. Save everything. All right, and let's assume that everything is made out of steel. So apply metal, and then we choose steel on the entire assembly, and we say OK. Good. Save everything. We will now notice that there is a planar symmetry here. Because of the nature of the loading and restraint, XZ is a planar symmetry. So eventually I'll come back in a different video segment. I'm going to cut these things. But for now, we just do it like in the book without any planes of symmetry. All right, so let's go ahead and, sorry, my phone is ringing, but that's okay. So analysis and simulation, generative structure analysis. So CATIA immediately sees this solid object and it's going to mesh it. Okay, now, if you follow the approach that is done in the book, you will get a solid, because the solid object was made here and the surface was extracted, you will get a solid, also the bottom solid object is going to get meshed. You have to delete that particular, the mesh that goes with that, and delete the 3D property that comes with it. But there is no such a problem here because we just have this, we just have the cylinder. If you, in fact, you can look at the cylinder, and only the mesh for the cylinder is going to be shown because only solids are meshed automatically. So deactivate. Okay. Deactivate. Let's move on with the rest of the problem. Now let us go ahead and mesh this surface right there without using the advanced meshing tool. Okay, so go find the shell mesh, which is right here. It's called Octave Triangle Mesher. You select the surface. Let's make it smaller, maybe probably 0.1. Let's see how it looks like, and everything is made with linear elements. Yeah. And by the way, we can apply a thickness to, have to apply a thickness to this shell. So we apply the thickness. I don't know what is done in the book, but I will use 0.1 inch. Okay, so it may be different in the book, but that's okay. On the test, you have to follow the instructions, but here I'm showing you the process. You can read the book carefully yourself. So if you look at the mesh now, you not only have the mesh for the solid element, you also have it for the shell element here. By the way, you can change the color of these things if you like. For example, I can go and take the shell mesh property. sorry, properties. Under the graphics properties, change the color if you want to some other color like that. Okay, not a big deal. All right. The next thing, let me deactivate this. The next thing you want to do is you want to mesh these with beam elements, right? With beam elements. Okay. Now, so let's see. Beam elements are over here. You have to do that manually. Now, because this was drawn as a wireframe, I did not have to join it. Okay, but if this was a sketch, if these lines were made as a sketch, you have to join. But I don't have to do that. So the size of this is 0.2, elements are 0.2. That means that there's going to be about 10 elements or 10, 15 elements through the height of this, okay? And, right, and let's do the other one too, this one too. I want to do them separately. We could have been, yeah, they have to be done separately as far as I know. Okay, now, let us say that the cross-section of this is square as shown in the book. Let me see now. The drawing shows that the cross section. Where is that? Seems to be square. Okay, so let me assume that the cross section is square with a dimension 0.1 inch by 0.1 inch. So let's go ahead and see whether we can do that. This is the 1D property, and you change this thing to okay. The support is let's do this one at a time. This right now it says cylindrical beam. We wanted a rectangular beam. Just give it time. All right, and the size of the size of that rectangle, I said 0.1 by 0.1. If it's too big, we're going to change that. 0.1 by 0.1. And remember, because it's a rectangle, it's not a circle or a tube, you cannot close this thing because it's asking for orientation point. So select for the orientation point. We have a point on this side, we can select it. And if it's giving you a hard time, why don't we hide this? Let me see. Let me hide this. Hide the sketch. I take it now. Hide this sketch. Right there. And watch what happens when I do that. This thing becomes aligned exactly like the way I want it to be. Okay? And say okay. And now we do exactly the same thing on the other side. So let me bring this thing into the show mode. And let me hide this guy. Actually, we may not need to hide it because we can select that point. So once again, we select the 1D property. The support is here. It's a rectangular beam, 0.1 by 0.1, and for the orientation point, I pick the point on this side. The only reason that I could not pick it before this point because there was a sketch sitting there, it would not let me do that. Okay, so you can see that they're both in the proper orientation, 0.1 by 0.1 inch. Okay, now if you say show me the mesh, it will show you everything. Why don't I change the color of this to something else? So maybe let's see now. Properties. Can I change the color to green? Ah, there. You see this? It's just for visual purposes. Properties. Change it to green. Okay. Let's go ahead and save first of all this file. Where's that file? Save management. Analysis, save as. This is the chapter 19 with no symmetry. Of course, subject to the modifications that I made. And let's move ahead. So I'm going to deactivate the mesh. The top of this is clamped. And also clamped on this side. I could have selected them simultaneously. And then the bottom of this is also clamped. Bottom of this cylinder is also clamped. Okay. And now we apply pressure here. I don't know, maybe I think it was 100 psi. I'm not sure, but I'll put 100 psi. Make sure that it is in the proper direction. Oh, this is pushing it up, so double click on this and change it to minus, so that the pressure is applied from the top, pushing this thing basically down. All right, so save everything. Now, if I run this, it's going to bomb out because these pieces are not connected together. Okay, they don't see each other. They don't respect it. Let's check it out. So let's run it and see that it will miserably fail. There we are. And if you look at the deformation, there's going to be rigid body motion, and they don't see each other. This horizontal sheet goes through the vertical cylinder. So we have to create connections and declare them accordingly. All right, so let me first deactivate this plot. All right, so first of all, I have to decide, let me hide this sketch too. We have to decide how these are connected. I mean, it could be that this hole is, the cylinder can slide up, or the sheet, the horizontal sheet can go, or plate can go up and down this thing without any, just pressing against it. That is called shell-solid interaction or contact, shell and solid contact, but unfortunately it's not available in CATIA. Okay, so what we're going to do, I'm going to assume that the periphery of this circle is completely glued, welded, or fastened with the periphery of the cylinder. So the first thing I need to do is to create a connection, and let me call this thing plate. What did I call this thing? Cylinder and plate, I think. Yeah, cylinder, plate. Oh, plate. So the first component is the surface of the cylinder, and let me hide this thing. And for the second component, I select the surface of or the periphery of that hole. Okay, and we can see that that is our first connection right there. Okay, then I'm going to create one between the left. Let me see now, the left column and the vertex and the plate. Okay, so another connection between. Okay, I have to hide this. First connection is going to be, or first component is going to be this. For the second component, I'm going to bring the plate in front of me. Okay, and I'm going to have to select the vertex of this, face. So let me hide that and hide the connection there. For the second component, it's going to be this guy. And I'm going to call this thing left column dash plate. Okay. Now I do the same thing exactly for the right one. Okay, another connection. Let me hide this. End of that line. For the second component, bring the plate in the show zone. Hide this. And I want to take that point, but it won't let me do that because that white dot is in my way. So I'm going to hide that white dot, and I can select the corner vertex. Good. All right. Oops, I forgot to change this thing. So I should call it right column dash plate. Okay. If it's bothering you, you can bring all of these and look at them right there. Everything is, my model is right there. Where are the lines, by the way? The lines are here. Bring this thing, hide and show, hide and show. There we are. Okay, now we created we created these connections, then we have to declare them. The first one is going to be fastened. So look for the face-to-face connection, find the fasten. So this one is going to be fastened. Notice that it puts a fastener sign there. These two, it makes sense to call them fasten, but unfortunately point to point, or vertex to vertex actually, not point to point, cannot be fastened. What can I do? I did not write the code. Okay, so what you need to do is not under the face-to-face connection, but under the distance analysis connection, right there. See that? There are the face-to-face connection properties, and then there is distance analysis connection properties, and vertex to vertex should be rigid. So you select this, you select that guy, makes it rigid, and you select it again for the second one, makes it rigid, and we're going to run it. Hopefully we didn't forget anything. It's not everything. We didn't forget anything, and we can run it. So let's try it. Before we do it, let's save the analysis, just in case something goes wrong. We have to kill the job, so I'm sure this is going to work. Done. So let's look at it. I change the scale so that we can see what's going on. There we are. And animate it. Don't let this thing fool you. Actually, if you look at the view from the front, everything is symmetrically deformed. Okay. Look at the deflection. There's the deflection. You can change it to average ISO. And if you don't want to see these elements showing up, remember how I got it to show? I go there and say, don't show me edges and points right there. Okay, and you can animate it. If you want to see the 1 meter stress, there we are. Now, beam elements do not show 1 meter stress. That's why nothing shows up here. Okay, if you want to see, for example, only the shell 1 meter stress, or if you want to see only the solid 1 meter stress, you double click on the 1 meter stress and you select and say, show me just the solid vertical cylinder right there. You see this? Before, because the shell was deflecting so much, there would be gigantic stress, 1 meter stress in it. We would not even be able to see this. Everything was blue there. But it does actually have a stress. Okay. Now, what I'm going to do is, after I'm finished with this, and we're pretty much done, I'm going to come back and cut this thing and then repeat the problem with symmetry. Okay. So first thing, save. Because I want to make the cut, let me put my parts and product in a different folder. So a file, save management. Where's the product here? The product is right there. Save as a desktop, chapter 19, a new folder, chapter 19, one plane symmetry, one plane of symmetry. And let's see now. This is okay. And make sure you say propagate directory so that it takes the product and the parts and put it in there. Okay, I can cut these. I can cut that and go and find that folder. And that folder, let's see if we can find chapter 19. Must be this one plane of symmetry. Notice that one plane of symmetry, the product and the parts are there, and I can go and do the cutting. Okay, so I'm going to stop this and repeat we'll do the next segment in a different video.